sold from 1999 to 2005. If this trend continued, about how many CDs were sold in 2006? Okay, well, let's look at the x-axis. The x-axis is all what? What does it represent? Years. So where would 06 be? Right over here at the very end. So if this trend continued, don't you think we'd have another point about right here? And so how many CDs is that? 650 million. Because remember, the y-axis is million. Number 2, the table below shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. Draw a scatter plot and describe what relationship exists within the data. Okay, so the first thing I want you to do is plot these 5 points. So like 3, 10,700. We go right 3 for the age of 3. Here's 10,000. There's 11,000. So 10,7 would be about right there. Okay, now I'm going to do the remaining 4 points. At 6 years old, so I go right 6. The cost is 11,700. So about right there. At 9 years old, the cost is 12,600. At 12 years old, the cost is 15,000. And at 15 years old, the cost is 16,700. So about right there. Now, they didn't ask us to do a line of best fit or anything. They just asked you to describe the relationship. What kind of relationship or correlation does this data have? Strong positive. Alright, make a scatter plot of the data in the table. Draw the line of best fit. So this time we have 10 ordered pairs, so we have to plot over here on the graph. How do I plot the point -2, +2? Left 2, up 2, because the y value is positive, correct? So we need to go up 2. How do I plot -2, +3? Right. Okay, what about -1, +2? Okay. 0, 1? Just go up 1. What about 1, 0? Just right 1. 1, 1? Correct. 1, -1? 2, -1? 2, -2? And 3, -2. Okay, now they want us to draw a line of best fit. What do they mean? Right, a line where you're trying to either go through the majority of the points or at least get close to it. Okay, so there's my line of best fit. Now, once I've drawn the line, they want us to write the equation of that line. Anytime they're asking for the equation of a line, what are they asking for? Right, the slope and the y-intercept, which is y = mx + b. That's the equation of a line. Okay, m is the slope, b is the y-intercept. Well, one of those two can be found very easily by just looking at the graph. The y-intercept is 1. So I can go ahead and plug in a 1 right here. So y equals mx + 1. Now, m is not quite as easy to find. How do you find the slope? Rise over run, but it has a special formula. Right. y2 minus y1 over x2 minus x1. Well, to be able, x2 minus x1. To be able to use that formula, what do we have to have? The x and the y, so 2 points, right? Now, points are always in the form x, y, correct? Okay, so let's pick 2 points over here. Maybe this one would be a good one. What are its coordinates? Okay, -1, 2. And then maybe, how about this one? What are the coordinates of that one? 3, -2. Good question. Which one? We have two. So for that reason, we have to give them a unique name. Isn't this the first point we found? So since it was first, you put a 1 on its x and y. So that's x1 and y1. This was our second point, so we put a 2. And now they all have a special name. So now if I said, what's x2, you would know to tell me 3. And now we need that to be able to put them in this formula. So in the formula, what number comes first? Okay, what is y2? Minus, right, over. Okay, what happens right there? Correct. A negative and a negative make a positive. Some of you aren't paying attention. Negative 2 minus 2 is, and 3 plus 1 is, what's negative 4 divided by positive 4? Negative 1. Remember, anything divided by itself is 1. Okay, anything over itself is 1, but since it's a negative over a positive, it's negative 1. Okay, now, that's our line of best fit using 2 points, the slope formula, and finding the y-intercept. On Friday, we learned how to find the line of best fit using the calculator. So now let's use the calculator and see just how close we were. Okay, so let me pull up my calculator. Okay, this is what I want you to do first. Pay attention. Everybody on your calculator hit second, the blue button, and you'll see that up arrow flashing. Then go over here. You see the plus sign? What's above the plus sign in blue? For memory. That's what we're trying to hit here is memory. Now, we want to reset all the memory. So hit 7, and then 1, and then 2. And it'll reset your memory. And now it just takes the calculator back to its default settings before people plugged in all this stuff. You know what I mean? Second plus sign 7, 1, 2. Second plus sign 7, 1, 2. Okay, now to put in these coordinates. Does anybody remember the first thing we do? Stat. Good. Then edit, because we're wanting to enter information. Now that everybody did the second plus sign 7, 1, 2 and cleared your memory, everybody should have L1 and L2. Sometimes kids will accidentally delete that out when they're trying to just delete the numbers, and then all of a sudden it starts at L2 and L1's missing. That means you need to reset the calculator to go back to the default settings. Okay, in L1, we're going to place all of our x values. Okay, so what are our x values? Negative 2, negative 2. Remember, we're doing the same. We're still on number 3, but since we found the line of best fit by hand, now we're going to use the calculator to see how close we were. Negative 1, then 0, and then there's 1, 1, 1, and then 2, 2, 3. Okay, those are all your x values for the table in problem number 3. Now we need to go over to L2, make sure you're at the very top, and you're going to type in all the y values in that table. So 2, 3, 2, 1, 0, 1, negative 1, negative 1, negative 2, negative 2. Okay, once the data is in there, once you have all your x values, all your y values, does anybody remember what to press next? Go back to stat, but this time, calc. And what is it we're trying to find here? The line of best fit. 4. So number 4, look, doesn't that look just like mx plus b? They just used the a instead of an m. So hit 4. And then this should automatically show up for you. It's just saying your x values are in list 1, your y values are in list 2, which they are. And now we're ready to calculate it. Okay, and look, a, which is slope, is negative 0.96, b is 0.78. So let's write that down. Y equals negative 0.96 and then plus 0.78. Was that pretty similar to the equation we've got by hand? I'd say so. -1 and -0.96 are very close. And then the y-intercept's a teeny bit off. We said 1, they're saying a little below 1.78, but I think we did a pretty good job of finding the line of best fit. Okay, now I want you to do number 4. Do all parts of it. It'll take you a few minutes. Go ahead and look at it. The hours range from 0 to 5. So on my x-axis, that's where I'm putting hours, and I'll just 0, 1, 2, 3, 4, 5. Okay? The grade ranges from a 60 to a 92. So I'm just going to start with 60 right here. And then I'm going to count that as like 65. So this would be 70, 75, 80, 85, 90, 95, 100. So for my y-axis, the scale is from 60 to 100, but the intervals are jumping by 5s. Okay? If you didn't do yours exactly like this, it's okay, but you have to have the hours on the x and grade on the y. Okay, now we're ready to do our scatter plot. So 384, right 3 up 84 would be about right there. 277 would be there. 592, 170, 060, 490, 375. Okay, who can tell me what this little thing right here means? Right. It means we skipped a lot of numbers. Because like from here on the x-axis, we didn't skip any numbers. We went from 0 to 1. From here, we skipped from 1 to 59, right? And that's what that represents. Okay, now that you have your points, we're going to draw a line of best fit. So like maybe something like that, maybe. Okay. Now I want to write the equation for that line. Remember, all equations of lines are in the same form. Y equals mx plus b. Okay, what can we go and find first? Okay, what is the y-intercept? 60. Okay, remember, the y-intercept is where it crosses the y-axis. Well, it's 60, and the chart even let you know what the y-intercept is. When x is 0, that's your y-intercept. Think about it. To have a point sitting directly on the y-axis, wouldn't the x value of that point have to be 0? Otherwise, it wouldn't be sitting on the y-axis unless its x was 0. Okay, so I know so far that it's y equals mx plus 60. How is it that I find my m? Right, the slope formula. But to be able to use that formula, what do I have to have? 2 coordinates. Okay, so let's pick out two, or I'll write them up here so I have some room to actually do it. Maybe let's use the y-intercept as one of them. You can do that. So 060 is my first point. And then maybe go with this one as my second point. And where is it located? 490. Okay, so when I get ready to plug those in, what number goes in the y2 spot? 90, and then minus over, okay, which becomes what over what? Okay, and then let's reduce that to a decimal value. 7.5. Okay, you didn't get 7.5? No, 30 over 4. I didn't get those points. It is 7.5, yes. Okay, so now let's put it in the calculator. Let's put these coordinates in the calculator and give ourselves a new equation to see how close it is. Okay, so let's go ahead and put these coordinates in our calculator to see how close our line of best fit is. Okay, so what do I hit first? Stat, edit, and then I need to clear out the data that I put in for the previous problem. Okay, now I'm ready to enter this data, so let's see, 3251, and then 060, 77. Oops. 9270. 6090. And 75. Okay, once you've entered all of your X and Y values, now what do you do? Stats. Calculate. Number 4, right? And then calculate. And you get your A, which is slope, 6.3, and your B, 62.04. So 6.3 and 62.04. So we were pretty close. Our slope was a little bit larger. Maybe we should have brought our line down a little bit, like maybe right there, and then maybe our slope would have been a little closer to 6.3. So do you see how that when you do it by hand, just how much room there is for error? Okay, now that we have an equation from the calculator, predict the grade for a student who studied for 6 hours. Okay, well hours is what variable? X or Y? X. So that means 6 is going to go where in the equation? X. So Y equals 6.3 times X, which we've just been told is 6, plus 62.04. So you're just going to type that in. 6.3 times 6 plus 62.04. Go ahead and be typing that in. Well, it's got to be bigger than that because you're adding 62 to it. Oh, yeah, you got to add 62. 99.84. Okay, 99.84, which, yes, in the grade book would be a 100. Okay, could this line go on forever?
No.
Why not? Ends at 24. No, you could study more than one day. But why? It is no, but why could it not keep going up? Right. Right. The max grade is 100. Okay, now turn to the next page. Turn to the next page. Okay, I want you to go ahead and try 5A. Work on 5A. Try it. Look, they've given you 2 points. What do you label this point? X1 and Y1. What do you label this point? X2 and Y2. Now, they gave us those 2 points so that we could write the slope-intercept form of equation for the line. What is an equation of a line? What form? Y equals mx plus b. What is the m of it? Slope. What is the b of it? Y-intercept. Turn around. The y-intercept is very easy to see when you're given a graph. Where does that graph cross the y-axis? We'll say about 12.2. So in the b place, we're going to go ahead and put 12.2 because we can see that that's where it crosses the y-axis. Now the m isn't as simple, but we know the m formula, the slope formula is y2 minus y1 over x2 minus x1. Now that we have those points and we labeled them, you just plug them right in. So what goes in the y2 place? And then minus what goes in the y1 place? And then what goes in the x2? And what goes in here? 2001. Okay, what does that become? 1.15 or 1.2 if you'd have rounded to the tenths place. Okay, now I want you to use this equation to find the price of a ticket in 2009. Okay, so when you take that equation, 1.15, and multiply it by the x value of 2009, and then add 12.2, you get 2,322.55. Now, Does that sound like a realistic price for a ticket to a game? No. Well, depending on the game, but considering this scenario when a ticket price was $22 or $24 in '06, do you really think it would have jumped to that in '09? No. This is the problem with this graph. Since there was a break in the graph and it jumped from 0 to 97, the y-intercept in the calculator is totally different than 12.2 because when you're, like if you were to calculate this with the calculator, the y-intercept would be totally different because it would go all the way back to 0, where ours didn't. So what you would have to do is you would have to renumber this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what, that would be '07, so that would be 10. '08 would be 11, so what would '09 be? Now put a 12 in right here and see what you get. 1.15 times 12 plus 12.2. I got 25.64. Is that what y'all got? Like, did y'all type in exactly what you see? 1.15 times 12 plus 12.2? Well, look, I'm typing it in. Look. 1.15 times 12, that represents 2009, 12 years since we started collecting this data. Guys, I'm trying to finish. Plus our y-intercept of 12.2 doesn't, what did I type? Oh, I accidentally typed in 1.12 on mine. Doesn't $26 sound like a more reasonable ticket price for 2009? Yes. So that's what was wrong with it. You had to renumber it like that. Your homework is 6 and 7. I will be coming around to check it tomorrow, so make sure you finish 6 A and B and 7 A, B, and C.